to them this time. All right. So again, on the quiz tomorrow, I'm going to change either this number or that number or both. So I would, if I were you, take notes because I'm letting you use this tomorrow, right? And the only thing that's going to be different is that middle term number and the initial height number. Okay? So everything else is going to be the same. The first thing I want to do is make a little sketch so I can understand what's going on. Maya shoots an arrow upward. The height, h of t on the arrow, t seconds later, is given by the equation h of t equals negative 16, which is the gravity constant, right? T squared, where t is time, plus 115t plus 5, which is the initial height. 115 is the velocity, right? So let's draw a little sketch. My y-axis, there's my x-axis. I highlight the first quadrant because that's where the action is, right? Instead of y, I call this h, the height. And then instead of x, I call it t for time. So, Maya's at an initial height here of 5 feet. Well, there's 5 feet. I don't think it's going to make a bit of difference, but she shoots us our arrow up, and then it comes back down and hits the ground. And of course, we're interested in 2 points, right? The vertex, which is x comma y, or in our case here, t comma h, right? So that's maximum height. And this would be the time that it reaches its maximum height. Okay, so that's what the vertex tells us. And then we're always interested in this point, right? This is the 0, which calculator calls 0, because our y or I should say our h equals 0. It's also called the x-intercept, or in our case, the t-intercept. So once we find those 2 points, we'll be able to fill all these questions in, right? All right, you ready? Here's what I do. And I highly suggest that you clear everything out of your calculator. Make sure your stat plots are off. Remember, there's a stats course in here, and they like to turn these on. So make sure they're turned off, and you do that by highlighting it and hit enter. Okay? See how you can turn them on and off? Make sure they're off. And then we're going to default to our zoom standard window. So zoom, hit the zoom button, go down here to standard and hit enter. Okay. It defaults to our negative 10 to 10, negative 10 to 10. All right. So I'm going to go ahead and put this equation into my y equal button. Negative 16, and instead of t, we're using x, right? So x squared plus 115x plus 5. And I'm going to hit the graph button. Now, if you've done enough of these, you don't have to really get it into your window, but I highly suggest that you guys make your window really, really small, or I shouldn't say small, smaller by increasing the Y maps on your window. So you can see your parabola. What? It said error? Now, a lot of times that'll happen if when you put it into your y equals, you use the minus sign instead of the negative sign. Make sure in your y equals that negative sign is made by this minus sign in parentheses. Otherwise, your calculator will come up error. Did it work? Okay. All right, so I know I got a parabola here. It's just that my parabola is like way up here, then there's my max, and then it comes back down, and here's the other side. Now, you could probably do all the calculations but it's kind of hard. So let's try to fit this in our window so we see the whole parabola. Now, this middle number was 115. Okay, that's that b term, right? Ax squared plus bx plus c. When b is a big number, or actually any number, it's exponentially bigger. Okay? If it were the c that was 115, I'd probably put 150 in and we'd be fine. But here, it's exponentially bigger. So I'm going to go to my window, and for my y max, I'm going to put like 500 in there, because I want to see where it's at. And hit graph. And actually, it's not that bad. I mean, we could go a little smaller. We can go a little smaller, but I can work with this. But just to make it a little smaller, just so for teaching, maybe I'll put 300 in there. 450? Or 350, yeah. Let's see what happens. Actually, 300 works pretty good. Yeah. Okay, so I'm going to find the vertex. In this particular problem, the vertex is the maximum. Okay, so I'm going to go to my calculate menu. And the way I do that, and this is on those little blue note cards, which you can use on the test. You hit second trace, and that brings up the calculate menu. I want to calculate the maximum. So I'm going to scroll down to 4 and hit enter, or you can hit number 4 in the keypad. Okay. I'm going to hit enter. And it's asking, are you to the left? Give me a left bound on the vertex. So I'm going to, anywhere left of the vertex will work. I'm going to make it just a little closer. I'm going to hit enter. I put my left bound in there. Then it's asking, well, give me a right bound to determine where that vertex is. So I'm going to use my arrow keys, get my cursor over to the right of it, hit enter, and then it's asking me, do you want me to guess where that point is? I'm going to hit enter again, and there's my vertex. Let's see, 3.6, comma, and I'm at like 211.6. Okay. So there's my vertex. Remember, this is my height, my h. This is going to be my time when I hit that maximum height, h. So all I have to do is fill in the questions. What is the maximum height? The maximum height is 211.6 feet. And when does it occur? 3.6 seconds. Okay, when does it hit the ground? So now I got to find the 0 or the t-intercept. So I'm going to go back to my calculator, go to my calculate menu again, right? So I'm going to hit second trace to bring up the calculate menu. This time I want to find the 0. So I'm going to hit enter. And again, it's going to ask me left bound, right bound. Now I'm looking for this point, the x-intercept, right? So technically I'm to the left of it already for the left bound. I'm just going to bring it a little closer. Okay, hit enter. Now they're asking for the right bound, or you have to get to the other side of the x-axis. Okay, so bring your cursor down below the x-axis, hit enter, and hit enter again. And I get 7.2 is my x, or t, so 7.2 seconds. And you guys see that little, let me zoom in on this. Yeah, it's got that weird y equal 1e to the negative 11. Well, that's your calculator saying y0. Okay. What it's actually doing is it's really trying to get as close as possible to 0. It's trying to give you a really accurate number. 1e to the negative 11 is 0.00000 11 zeros 1. So it's really trying to get to that most accurate number, but it has to stop at some point. So whenever you get an e to the negative number, that means it's 0 on your calculator. Okay? And that's going to happen when you go to college, because everyone's supposed to go to college. That's why they're taking this course. No matter what degree you get, you're going to have to either take a stats course or a general math course. And you're going to, even on those calculators, you're going to do a lot of calculator work, and we're going to do more calculator work. Those calculators are going to do the same thing. They're going to give you e to the negative 10 or whatever for 0. So it's something you're going to have to watch for. All right, so then it wants some other values here. Okay, it wants to know the heights at different times. Well, this is actually pretty easy. This is one of the easier ones. Just go to your chart. Okay, to go to your chart, you hit second graph. It brings up the table, and there it is. So at 2 seconds, it wants to know the height. It's at 171. 171 feet. At 3 seconds, it's at 206 feet. And at 4 seconds, it's at 209 feet. Okay? Now, because because it made a trajectory of a parabola, it doesn't have constant slope. It has a changing slope, right? Well, it makes sense because the arrow goes up, then it doesn't go at a certain speed all the time. It slows down, and then, so the slope isn't constant. It's a parabola. It's a curve. So what we have to use is the average rate of change. We have to get like an average slope. That's what that kind of means. And the average rate of change, the way we find that is the change in h, because we're h instead of y, right? Over delta t, or the change in time. And that's exactly what slope was, right? Delta y over delta x, y2 minus y1 over x2 minus x1. So, the change in time. Be careful here. Okay? These are going to change on the quiz tomorrow. It'll probably be from 1 to 3 or something like that, or 1 to 2. This is from 2 to 3. So that's my t, or x. So 2 minus 3 goes on the bottom. And then the change of y, or the change of h, let's see, between 2 and 3. 171 goes with the 2. Minus 206 goes with the 3. All right, 171 minus 206, and I'm not going to trust myself this morning. So early in the morning.
35.
Is it 35? To get back to my regular calculator menu, hit the second mode key and it brings up just the computation screen. So I'm going to take my 171 minus 206 and I get negative 35 over negative 1. So it becomes 35 feet per second is the average rate of change. Okay, so that problem had just about everything in there. Let's do now. You guys worked on this yesterday on the slide, right? What's a function? Okay, the domain, we told you this yesterday, are all the x values. This is a set of points. So the domain is a set of points that contain 9, negative 2, 3, and 9, which I already have, so I'm not going to put it twice. And then my range are the y's. It's the set of points 4, negative 1, 2, and then 5. Now, you can't use the vertical line test in this one because we don't have a graph. You have to determine, just by looking at the points here, is this a function? No, because it has the repeating 9s, right? Okay, so no, it's not a function because we have two numbers, we have two outputs for the number 9, for one x input. And that's part of the definition, okay? There are, even if you put something like there are repeating 9s, repeating x values. Okay? In other words, we have two outputs for the same number 9. I would even take something like that. Okay? Now, let's go to your other sheet. Oh, sorry. You guys good? All right, let's go to your other sheet. Let's do graphing some functions. And I'm going to do one of each. Okay, vertex form is actually the easier one. Vertex form where we have y equals a times x minus h squared plus k, and my vertex is hk. Now be careful, the h has different signs, right? The k has the same sign. So the first thing you want to do, you're going to need 3 points to graph anything, any function, right? So you always want to find your vertex first. Vertex form is easy because you can just kind of pick it out of the equation. Okay? My x value is the inside the parentheses, opposite the sign. So it's 4. My k is same sign, is 4. Then you want to pick one less, one more, and get those y values. Now, I think I made you guys do this manually. Maybe not. I know I did my Algebra 2 classes. We're going to do it the easy way. Okay? I'm going to go ahead and plug that into my y equal button again. Okay, so I'm going to go to y equals, clear it out, going to go to my zoom, going to hit my zoom standard, default my graph. I'm going to go back to my y equals, and I'm going to put this in there exactly the way it is. 2 times x minus 4, close it off, square it. Now you might have to use your arrow keys to get out of that squared, plus 4. I'm going to graph it. I don't even care if it's on the screen or not because I'm not even going to look at it. I want the table. So I'm going to go to my second graph and scroll down here to 3, and my y value is going to be 6. And of course, my 5 is also going to be 6. So there's my 3 points. Going to graph it. Let's see, 4, 4, 4, 4, 3, 6, and then 5, 6. You got a question? You good? Here's my parabola. Okay. Then it says you're going to have to label the axis of symmetry. The axis of symmetry, or the line of symmetry, is nothing more than, yeah, it's the x coordinate of the vertex. If you want to go ahead and put it on there, there's my line of symmetry, or axis of symmetry, at x equal 4. Okay, or you can just write it out. Axis of symmetry x equal 4. Also, you're going to have to state the domain and range. Now, the domain, really easy. Okay, for this course, it's always going to be for parabolas, negative infinity, positive infinity. Okay, the range is what's going to change. Now the range, it's either going to be positive or negative infinity, and it's going to be the y value of the vertex. So I have 4. It's going up, so it's going to be positive infinity, so that's the bigger one, so it's going to go to the right here. Positive infinity, remember, always gets the parenthesis. The 4 gets the bracket. And then we're going to graph the same thing, the function, but this time it's in standard form. And you have to at least compute what the x coordinate is. Now it's standard form, ax squared plus bx plus c. You're going to have to at least compute the x coordinate of the vertex, which is negative b over 2a. Okay. So if I'm looking at my equation here, my a is the coefficient of x squared. So my a equals 1/2, and my b equals positive 2. Okay, you got to include the sign. If this was a negative 1/2, you would have to put that in there. Okay, so let's compute the x coordinate. X is going to equal negative, and my b is 2 over 2 times a, which is 1/2. You could either do this in your calculator or do it in your head. Negative 2 over, now half of 2 is 1. So my x coordinate is negative 2. And again, we're going to do this the easy way, right? So here's my chart, X, Y. I need 3 points. I'm working on my vertex. Excuse me. And my X value for the vertex, my X coordinate, is -2. Everything else I can get from my calculator. Okay. So this time I'm going to put the equation in there, and you got to be careful. Okay, any fraction, you have to put fractions in parentheses in your calculator. Otherwise, it does funny stuff. It actually follows PEMDAS. So I have 1 divided by 2, close that parenthesis, times x squared, I'm putting this equation in there, plus 2x plus 1. And again, I don't even care if I see this parabola because I want my table. I'm going to hit graph. Actually, I'm going to be able to see it. And give your calculator a second or two. Mine's still thinking. I'm going to go to my table, second graph, and pick up my values for y. So -2, there's my -1. And I'm going to go 1 less, -3, 1 more, -1. Looks like -0.5, and then -3 should be -0.5 too. So there's my 3 points. Okay, let's go ahead and plot those. My vertex, -2, -1. So you have -1, -0.5, and then -3, -0.5, and there's my parabola. Axis of symmetry, x equal -2, and then domain, always -infinity, +infinity for this course. And then range, let's say it's opening up, so I got +infinity. And, yep, my y value is -1. All right, what I'll do is I'll put this video on online in Google Classroom. I'll put the answer key in Google Classroom for all the other ones. Again, I'll let you guys use these on the quiz tomorrow, and we should have a very enjoyable quiz tomorrow.
Is this the algebra too?
Yeah. No, this is QLS.
What about?
I'm using.
What is this class?
Oh, QLS, quantitative literacy stats.